Hi everyone. Thank you all for coming today. So today we're going to be talking about cyber resilience in Industry 4.0, strengthening standards and embracing emerging tech. Classic page. So a little bit of background about myself is, hi, I'm Shaza. I currently work as a security innovation and development engineer over at Fujitsu. Prior to that, I graduated back in 2022 with a degree in cybersecurity digital forensics. During that time, I was a programming tutor, did my security internship at the Home Office, and the most fun one was working as a junior information security consultant over at the Northwest Cyber Resilience Centre, where we were helping local SMEs in order to build up our cyber resilience on a regional level. So, without further ado, getting into cyber resilience in Industry 4.0. Just a side note before we do get fully into this. This is a part of a really big research project I was undertaking at the time. This is all kind of my personal opinions and conclusions and research. And I've tried my best to do it in about 15 minutes, so hopefully you guys can take something away. So, Industry 4.0 refers to the four industrial revolutions, and one of the best ways to describe it is the current mass digitalization movement you guys are seeing across the board. They're often specific to industries like manufacturing or industries that often have been traditionally physical or network isolated, and it's referring to their movement into the advanced technologies we're seeing at the moment, so things like Internet of Things, machine learning, and our beloved cloud. So it's that involvement in these kind of sectors and the rapid advancements that sometimes security isn't necessarily at the forefront of. Now, it sounds like absolutely amazing news to see the advancements for these companies and industries across the board, but the slight downside of this thing is our attack surface area has increased significantly. So if you think about, prior to Industry 4.0, for the sake of simplicity, we had about perhaps 10 doors that an attacker or a threat actor could come and cause any, malicious or create any attacks. And now because of Industry 4.0 and so many, the Internet of Things and so many things being connected, we have a million doors for them to attack. And actually, 10 to a million is a big jump. And how do you take care of all of those million? After all, they always say security is never 100%. So the interesting thing about this is, if you have a million doors, which ones are you going to prioritize in this scenario? So I had the very same question. I thought, which ones would I prioritize if I had to take care of security on a national level? And the answer to that is critical national infrastructure. So critical national infrastructure is probably one of the most important things currently across the UK. Now, cyber resilience and critical national infrastructure. So if you guys don't know what critical national infrastructure, and you may have heard it being referred to as CNI or CI sometimes, critical national infrastructure is defined as critical infrastructure that could be the information, systems, processes, networks, people, that the disruption of them or compromise or loss of them could cause significant disruption to our essential services, which in turn could lead to severe economic or social or even loss of life at times. So that's all really fancy words to essentially say something happens to our critical national infrastructure, we're kind of screwed. So preferably to stay safe and resilient. Now, our critical national infrastructure, it sounds like really big and almost a really far away concept from us, especially as the general public or security people, where it sounds like it has nothing to do with us and it sounds like something to do with the government, it's national, and it's really far away. But the reality is it hits much closer to home for some people. So I know it's a classic example, but I'm sure lots of you here have heard of the WannaCry ransomware. And I know it's an overused example, but I think it's the best example to use in this scenario, because WannaCry ransomware is one of the few hits to our critical infrastructure that not only the security people knew about, but the general public is one of the few things that the general public actually understood and it impacted them on that level. So this happened back in 2017, and I wasn't even in security at that point, and I heard of WannaCry ransomware, and it's that kind of level where it's not just you've gone on, have I been pawned, and you thought, oh my gosh, my email's been leaked again. This is actual essential services being impacted. And as a reminder, the WannaCry ransomware cost us about £92 million to recover from, and it had 19,000 health cancellations across the board. So it actually affected healthcare on a national level. Now you're probably thinking 2017 sounds like a long time ago. We've advanced since then, and it's probably not as much of an issue, or we have security measures in place. And that's not necessarily true. So in fact, our National Cybersecurity Centre has reported a 64% increase from last year in terms of national cyber threats being detected. Bridewell Consulting also conducted a survey back in 2021 regarding our CNI operators across the UK, and 86% of them reported that they detected cyber threats, and 93% of those said they've had at least one successful attack. And again, these are the things that are just being detected at the moment. So many things are happening under the layer. And so when I was reading this, I thought, okay, all these scary stats are alongside the fact that the UK is the third most targeted country in the UK when it comes to critical infrastructure. I decided that I wanted to know more about the security measures that have been in place. How secure is our critical infrastructure and what's going on? Now, what I decided to do was research our cybersecurity standards, our frameworks, our policies, not just for cybersecurity, but for threat modeling and simulation. Now, the interesting thing about critical infrastructure is because it's so critical, you can't really take these systems offline. So what happens when you need to test the security of something that you can't really take offline for periods of time, and you don't really want to be the person testing on a live system either. And the answer to that is simulation. So simulated environments of the original process or system that you're creating, that's what needs to be done, to have a simulated environment and test it on that simulated environment. So I thought, fantastic, I want to see what security measures are being talked about in these legislations and standards in regards to that. So this is just a snippet of some of the standards, regulations, frameworks across the board that I've had a deep dive into. And I specifically looked at security assessments, in particular simulations. So I wanted to know if these security assessment sections of these actually spoke about critical national infrastructure, or if they talked about simulations and how those simulation environments should look like. The answer to that is almost none of the standards made any reference to critical infrastructure, and none of them at all talked about simulation either. Not basic level simulation, let alone high level simulation, let alone the standards that should include. None of the standards analysed made a clear or distinct separation in either the security assessments or the simulation environments to even introduce, address, or differentiate how simulated security assessments should look like in those environments. You're probably thinking, okay, fantastic, we've identified a bit of a problem, why isn't there a conversation about how these simulated environments look like? And when I read all those research and read all those policies and things, I thought, one, either all those critical national operators either aren't doing security assessments, which is unlikely, or two, they are doing security testing, but in their own interpretation of what those policies should look like in those environments. And that's fantastic, that's great, but the whole point of policies and frameworks is to have a base level standardization across the board to ensure that there is a minimal amount of security and an ability to measure from that point. So, digital twin technology. Now, I don't know if any of you guys here have heard of digital twin technology, but it is a form of simulation environment where you are essentially copying something, you're becoming its digital twin. So in this case, a smart city. You're taking that city and you're emulating it as closely as possible to the original thing. And the difference between that and normal simulated environments is simulated environments are often static, so they're limited to a designer's capabilities, their scope, and a limited amount of information. But simulations sometimes deal with the original the original version of it rather than the current version of it. So 3 weeks ago can look quite different to today. And digital twin technology actually deals with real-time data, which is the key difference between this. So digital twin technology, in this case, takes real-time data from the physical thing, hands it over to the digital twin. That in turn matures, adapts to the environment, it takes that information in, and in turn allows people to actually make informed decisions. It allows for monitoring, and it allows for real-time access and knowledge as to the current security environment in that time. So it's so once reading all of this, I thought, okay, it sounds like the simple solution, or even just a suggestion that not only should we really be talking in those standards, talking about critical infrastructure, and not in any detail that could give away to our critical infrastructure, but to talk about how you should be testing for these environments, and not only talking about simulation, but how that simulation should look like, to what level that simulation should be. For example, fidelity is a term often used when talked about simulations, and that is regarding how closely something is related to the original. So it could be 50% similar, it could be 60, 70, 80, 100, well, not quite 100%, but as closely as possible. And what is that measure? What is that baseline of how closely something should be related to for it to qualify? And how realistic is it to ask for it to be a certain level of percentage, for example? And how real-time is real-time data? And so I believe these things should be included in our legislation, not only talk about simulation, but talk about the standards of simulation used to ensure a baseline. So yeah, to summarize all of this, cyber resilience is incredibly important, particularly in our critical national infrastructure, which relates to which are involved in Industry 4.0. It's so important to want to advance and continue our advancements as a country. However, to make sure that we are being safe and secure and as resilient as possible to foreign threats and attacks. And one of the ways to do that is to ensure a baseline standardization and regulation across the board. And one of the formats this could look like is by suggesting that they use high-level simulations and specifying how that should look like. This is all from the research I've done, but is also reflected in the Cyber Strategy Annual Review of 2022, where the government themselves admit that CNI is now becoming a major concern and are actively trying to hold CNI operators more accountable on how they do security testing, and have potentially raised the subject of adding to legislation. So, hopefully I've covered everything for you today, and maybe you know some of this, maybe you don't. But I want to thank you all for listening. If anyone does have any questions, it's my LinkedIn over there, and I made a Twitter. And it looks like a bot because it's new, but I promise that's real. But thank you all for listening so much.
Don't mind if there were a few questions to try and catch more time.
Try it.
Do you feel that?
Because the guys that work within this area struggle to actually just meet within their physical environment these standards, that is somehow a little bit challenging for them to then, when they do a simulated environment, to then implement the standards that are already there for their existing environment. But then another viewpoint of you saying about fidelity and those sort of things are like having a look towards those sort of areas. Do you think that might put them off a little bit, or might give them an additional challenge when they're already like dealing with stuff within their physical environment?
That's a fair enough question. Of course, maintaining security is difficult for people across the board, even with, big corporations that aren't, as physical as some of these industries are. However, if you're choosing to adapt these technologies, that comes at a risk, and in some situations they have more to lose. So as challenging as it is essentially worth it, and I definitely do think it should be more accessible and more, and the government is saying they're committing to doing that by introducing, tools that are more accessible, maybe more affordable or cost effective in this sense. I think the conversation should be more about, this needs to happen, how can we make this more accessible, affordable, and easy to kind of monitor, rather than, oh, this is too difficult, let's not do that.
Thanks again, Shaza.
Thank you.